Let's jump right in. Get ready because we're about to take a high-speed descent into the ocean's most visually stunning and, frankly, utterly deceptive wonders. In this explainer, we're looking at creatures that look like they were painted by a surrealist. We're talking vibrant, glowing, mesmerizing animals, little exquisite jewels scattered across the seafloor. But, as you'll soon see, in the ocean, looks are almost always deceiving.
You know, marine biologist Dr. Stephen Haddock really hit the nail on the head. He pointed out that the deep sea is essentially an alien environment, and the animals there have evolved in ways that seem almost impossible to us. To truly get these creatures, we've got to totally throw out our human definitions of aesthetics. We need to rethink what beauty actually means out in the wild. So that brings us to the central mystery we're unraveling today. Why are these creatures so breathtakingly beautiful if they didn't evolve to impress us? I mean, they have no idea we're even looking at them. Well, the answer is pretty wild. What we perceive as breathtaking art is, in reality, a highly refined, fiercely competitive evolutionary tool for survival.
Down in the deep, the absolute golden rule is form follows function. Think of their beauty as a Trojan horse. All these dazzling appearances, the neon colors, the glassy bodies, the flashing lights, they aren't decorative at all. They're actually essential tools for camouflage, toxic warnings, and some seriously brutal defense mechanisms that have been refined over hundreds of millions of years.
Okay, let's dive into our first category, colors that warn and defend. We're starting with creatures that use these vivid, totally impossible colors, not to hide, but as a giant flashing warning sign, to just back off. Just look at the mandarin fish. I mean, it looks like something straight out of a fantasy movie with those electric blue, orange, and green patterns, right? But if you were a predator, you absolutely would not want to take a bite. Instead of having normal fish scales, this showstopper is actually covered in a thick, velvety, and incredibly foul-smelling mucus. It tastes terrible and literally acts as a toxic shield. And what makes the mandarin fish even cooler is how it actually creates that color. It's called structural coloration. Unlike most brightly colored reef fish that just rely on pigments, the mandarin fish is one of the only vertebrates on Earth to generate its brilliant, true blue hue through unique cell structures that physically bounce and reflect light. It's basically a masterclass in biological engineering. Next up in our gallery of dangerous beauty is the blue dragon nudibranch. This is a tiny sea slug, averaging just 3 centimeters long. It just floats out there in the open ocean looking like a delicate living jewel. But seriously, do not let its size fool you. This little dragon is a fierce predator that actively hunts the highly venomous Portuguese man-o'-war. And this brilliantly illustrates one of the most ruthless survival strategies in the whole ocean. The blue dragon eats its venomous prey, carefully extracts the stinging cells, which are called nematocysts, and then stores them in its own tissues. It literally steals its prey's weapons and wears them to deliver a painful sting to anything that messes with it. Talk about a power move. All right, moving on to the masters of camouflage, because sometimes surviving in the ocean means hiding in plain sight and blending perfectly into a very specific and sometimes totally alien background. To get how this works, we really have to understand how light behaves underwater. Up in the surface waters, yellows, bright blues, and greens help animals blend right in with the dappled sunlight. But as you drop deeper into the abyss, red light just completely fails to penetrate the water. So what does that mean? It means a creature painted in deep crimson red becomes functionally invisible. They're essentially wearing a color-coded invisibility cloak. Which brings us to a creature with a beautifully macabre name, the bloody belly comb jelly. It's shaped like a little heart, and when its tiny hairs, its cilia, beat to propel it through the water, it actually sparkles. But that deep crimson stomach, not for our amusement. In the pitch black of the deep sea, its red gut is perfectly designed to hide the glow of any bioluminescent prey it just swallowed. That way, the jelly itself doesn't turn into a glowing neon target for an even bigger predator. Now, back closer to the surface, hanging out in the kelp forests off the coast of Australia, we find the leafy sea dragon. It looks like it belongs in a ballet, right? Adorned with these elaborate frills that look just like a tutu. But those frills are actually perfect camouflage. By moving super sedately and using these tiny, almost completely transparent fins, the sea dragon completes the illusion that it's nothing more than a piece of drifting seaweed. Let's plunge back down into the darkest parts of the ocean for bioluminescence and light shows. Down here, the only light you're going to see is the light the animals make themselves. Now, what's really interesting here is the strategy of the Atolla jellyfish. It is pure genius. When it gets attacked, it doesn't just try to swim away. Instead, it emits a spinning wheel of flashing blue light. It's essentially a biological burglar alarm, and it's specifically designed to attract an even larger predator to the scene to eat whatever is currently attacking it. The enemy of my enemy, right? And the craziest part is that this light isn't just some random color. 474. That is the exact nanometer wavelength of the Atolla's deep cobalt blue light. Why that specific number? Well, because evolution is the ultimate optimizer. 474 nanometers just happens to be the exact wavelength that travels the absolute farthest through seawater. This guarantees the jellyfish's distress signal is seen by the absolute maximum number of potential deep-sea bodyguards. And these oceanic light shows have actually had a profound impact on human history, too. Take the crystal jelly. It produces this ghostly green halo using a molecule called green fluorescent protein, or GFP for short. Well, scientists figured out they could use this exact protein to illuminate living cells, genes, and proteins inside humans and other animals. This single survival tool from a delicate little jellyfish completely revolutionized modern molecular biology. It literally won the 2008 Nobel Prize in Chemistry. Okay, let's shift gears to symbiosis and shared beauty, because some of the most vibrant colors in the ocean aren't actually made by a single animal alone, but through some really radical, incredible partnerships. 550 pounds. That is the maximum weight of the giant clam, which makes it the world's largest bivalve mollusk. These massive, stationary creatures can sit on the ocean floor for nearly a century, but they're also home to some of the most stunning, iridescent patterns you will ever see in your life. So the reason for those vibrant blue, purple, and green patterns on their mantle? It's all about symbiosis. Giant clams have these clear spots, literally called windows, in their tissues. And these windows allow sunlight to filter deep inside their shells to feed billions of symbiotic algae living right inside them. The clam provides a super safe, heavily armored home, and the algae photosynthesize, basically paying their rent in the form of essential sugars and proteins. It's just a perfect, incredibly beautiful economic exchange. Which brings us to our final section, protecting our underwater masterpieces. As we wrap up this explainer, we really need to bring our focus back to the present reality. We've just toured this fragile, ancient biological art gallery, and right now, it is under severe threat. These marine masterpieces are facing an absolute gauntlet of stressors. We're talking climate change causing rapid warming and ocean acidification. We've got urban stormwater and agricultural runoff poisoning the water. And of course, solid waste, microplastics, and physical damage from overharvesting. These animals have incredibly, perfectly adapted evolutionary mechanisms, but they just cannot outpace the speed of our human-induced habitat destruction. These masterpieces of evolution, the glowing jellies, the toxic sea slugs, those massive giant clams, they have survived for up to 500 million years. I mean, they predate the dinosaurs. Their beauty is the ultimate proof of their resilience. Out there, true beauty is survival. But it leaves us with a pretty heavy, urgent question to think about. Will we step up and take the responsibility to protect this alien world before its colors fade forever? Thanks so much for exploring the science of oceanic beauty with me today.